Today we're going to explore a method that uses determinants to solve linear systems. This method is known as Cramer's rule. We specifically are going to restrict our focus only to solving systems of two equations, but do keep in mind that Cramer's rule can be used to solve higher dimension square matrices as well. So given this example, negative 8x plus 3y equals 10, and 10x minus 2y equals negative 2, we know there are different methods that we can solve this system: substitution, elimination, etc. We're going to focus on Cramer's rule. So in order to do that, the first thing we're going to need to do is rewrite the system in matrix form. So let's take the coefficients of our x's and our y's, and we're going to put them within matrices. Then we'll put in the other set of matrices the variables. And on the other side, we're going to set our constants. So if you were to do the multiplication of row by column, so negative 8 and 3 times xy, you'll end up with that equals that. The row by the column equals that. So you'll end up with those two linear systems. Now, we need to find D as in determinant of our given matrix. And so we are going to find the determinant of this matrix right here. So determinant of negative 8, 10, 3, and negative 2. So we multiply, and then we subtract the product of those two numbers. Simplify. We'll do the same thing now, but when you're asked to find the d sub x, what you're going to do in this scenario is you're going to replace the x column right here with the constant values. Okay, so this was our given matrix. Replace this column with those. Bring that down. We're going to go ahead and calculate the determinant again. 10 times negative 2 minus the 3 times negative 2. So negative 20 plus 6 is negative 14. Repeat, this time for our y. So we bring down this column, and this time replace this column with the constants, 10 and negative 2. Recalculate, negative 8 times 2 minus 10 times 10, and we get negative 84. Now, once you have done all of that, we can go ahead and find our x and our y by fulfilling that formula. So I'm going to raise this up a little bit. So x equals d sub x over d. So we're going to take the negative 14 divided by the d that we got, 1. It's the same thing for y. D sub y over d, the negative 84 over negative 14 and positive 6. Now, that's how you do Cramer's rule to solve the system. But let's employ a different method of solving systems to see if we do end up with 1 and 6 as our answer. So let's do that. Let us do, for instance, how about we do elimination? So how about we eliminate the y, okay, since we already have the positive and negative. So multiply the top by 2 and the bottom by 3. So if I multiply the top by 2, I'm going to end up with negative 16x plus 6y equals 20. If I multiply the bottom part by 3, I'm going to get 30x minus 6y equals negative 6. Again, what I'm doing is trying out the elimination method, just to show that Cramer is just another additional method to solving systems. So negative 16 and a positive 30 gives you 14x, okay, equals 20 minus 6 is 14. I need to divide both sides by 14, and x ends up being 1. So far so good, because that's the answer we were getting using Cramer's rule. We substitute x equals 1 into any one of the equations. So I'll use the original equations of negative 8x plus 3y equals 10. Substitute my 1. That will just make this negative 8 plus 3y equals 10. Adding 8 on both sides. 3y will be 18. And I'll divide by 3. So the y equals 6. Hope this helps you understand how to solve systems using Cramer's rule. Thanks for watching.